Good afternoon once again, and I extend a very warm welcome to our panelists today. Just for the audience, the way we are going to structure this, we'll have initial opening remarks by each one of the panelists. Then based on their opening remarks, I might go into some of the clarifying questions or some of the lead questions. So we'll probably go through 2 or 3 rounds. Then we will have an open house. And we are expecting at least 20-25 minutes on the open house, so to keep it more engaging with the audience. So why don't we go ahead and start? Mr. Mahesh, would you like to make some few opening remarks?
Yeah, good afternoon, everybody. My name is Mahesh Kapri. I lead supply chain for GE Healthcare in India. We have 4 manufacturing plants in India, the smart manufacturing plants. And we have been in India over 3 decades. We have the advantage of being a medtech company, having very good joint venture partners in Bell and Wipro, and building a very good ecosystem. Now, talking about pandemic, so much has changed in healthcare because of pandemic. For decades, nothing seemed to be happening, and in weeks, decade has happened. Digitization in healthcare is making huge impact in the way the patient administration and patient care is being taken care of. We have seen umpteen examples of what digitization can do in the model of how the companies run, how the supply chain has transformed. If I have to give you example, Airbnb is a $20 billion hotel service industry, and they don't own any real estate. Talking about Apple, which we all use, it's an $18 billion app economy, but they seldom do the apps on their own. And then, for all of us, we have heard about Uber, right? Uber, car service, taxi service, and they don't have any of the cars owned by them. Similarly, in the healthcare, we, as healthcare, GE Healthcare in particular, we generate almost 16,000 scans per minute. That's the kind of scans we generate from our connected devices. And AI and connected devices are having a huge impact in the way the healthcare is getting transformed. Now, if you really think of what the future of healthcare is, we think the future of healthcare is precision health. Many of us, kind of get confused when we talk precision health to personalized health. Precision health is all about reimagining medicine to prevent, predict, and precisely, address their disease. In the opening pitches, I think you heard a lot of beautiful things about Smart Factory. We do all of them, but not to repeat, maybe I will leave thoughts on few things that are also happening and transforming what's going on in healthcare, and leave my fellow panelists to bring in other aspects from the other industry, and then take the Q&A. So RPA is one thing, robotic process automation is one thing that's really redefining the future of healthcare. 3D, very, very interesting. The way Muller talked about it, 3D in our products, 3D parts for even detecting and solving some of the problems. But we are also using 3D in our manufacturing. We have got CT scanners where we have transformed complex parts into 3D parts, and they are in production. It was a huge enabler, especially during the pandemic when we had huge rise in the volumes. Some of these 3D parts, not only they solve the cycle time, but also fewer defects and fewer scrap and whatnot. Also, one other aspect, AI and connected devices, and then I'll leave other panelists to make their comments. Trained over thousands of images over different countries, different patients, different tubes, different detectors. GE Healthcare has designed an X-ray machine which can enable the doctors to detect neurothorax on multiple X-rays. We have seen examples of ECG machines where the auto ECG is there. Similarly, there are examples on ultrasound, And as I wind up, let me, switch subjects and talk a little bit on the supply chain innovation on the healthcare side, right? Uh, in our country, we are heavily import dependent. We bring a lot of equipments, medtechs, back to the country. We manufacture quite a few, but we also bring in some high-tech equipments. MR is one such equipment where, being supercon magnet, helium is used to cool it. With the supply chain challenges with pandemic, there was a huge congestion to fly things into the country, which would mean as the delay happens, there is more boil off of helium and that much losses and eventually delay in supplying the product. We re-innovated, reimagined the supply chain, wherein we moved to getting some of these warm magnets by ocean and kind of transfill and then serve the customers locally. So there is so much that pandemic has taught us, and I think this is just the beginning. With that, I'll turn it back to you, Vijay. Thanks.
Thank you, Mahesh. Can I now invite Mr. Nand Kumar to make some opening remarks?
Thank you, Mr. Vijay. And first of all, I would like to thank CAI for inviting me as a panel here. I'm coming from a factory automation company, FANAC. We have our manufacturing only in Japan. We only do marketing and servicing of our products here. The main products are CNCs and industrial robots and robo machine. We are global leaders in CNCs. The main thing behind FANAC is that the products are made which are reliable, predictable, what Mr. Carson said, and easy to repair. I think these are the three main things which is behind our R&D in Japan. 1/3 of our employees are in R&D. And being from CNC machine tool and industrial robots background, I would briefly touch on AI with IoT later, how it helps in improving productivity, quality, and also reduce energy in some cases, and also dependency on skilled labor is not there anymore. So that is the thing which I would touch upon later, and a couple of very short videos on industrial robot application, one on welding, one on metal handling, both with collaborative robots, just for people to view how the future of manufacturing can be with latest advancements in hand guidance function, what we call, and also with vision system. So thank you so much.
Thank you, Mr. Nand Kumar. Over to you, Mr. Muralidharan, for your opening remarks.
Yeah, good afternoon. Thank you, CI, for giving me a chance to share my views. Here again, I won't be particularly talking about my company. I work with the Tata Group for the aerospace and defense industry. And my experience I'm sharing is in general in the military industry. So manufacturing in military industry is very different from the other industries. I feel very jealous about the other manufacturing experts who talked about automation, high speed, etc. In military, we were the original innovators, the mother innovator. All technologies were innovated in the military and flew down to the civilian market. Of late, the reverse is happening. The military is copying 5G, AI, machine learning, manufacturing technologies, SCM tools, all of that. So we're trying to now catch up with the civil industry. Like the military weapon systems, they are made very few in numbers, right? Maybe 10 guns a year, 100 rocket launchers in 5 years. So the number is very low, high complexity. So you cannot afford to have automation, right? So you need a skilled manpower, talent at the shop floor level to integrate. Somebody was talking about design for manufacturing, okay? So that word is always there with us, because if we make a complex weapon system that cannot be manufactured, it's of no use, right? So we expect certain talents to be in the shop floor to create or make our machines, though it's well designed. Maintainability is important in the field. In the battlefield, if something goes wrong, the enemy will not say, okay, stop the war for a few minutes till I fix the machine, right? So there are a lot of these challenges in the military industry for manufacturing. Yes, consumables like the shells and rockets, they are made automated because you need a lot of them. Otherwise, the machines, you need a lot of variants. But what we discovered from the civil industry is that there are many tools available to keep track of bill of materials, variants, all of that we have adopted. And it's fully digital company, digital manufacturing, everything is digital, though the system is also digital. But the process of manufacturing is still manual because the number of systems that you have to manufacture in a year, right? So this is one challenge that we are facing, especially the military industry world over. So if you look at the military industry world over, it's $2 trillion US dollars. That's the industry world over. Still, automation is not there. In a way, it's good. It gives employment to a lot of skilled labor. But what we find the major problem is when the skilled people move, leave, we have a backward. To keep continuously training them is very difficult because not many industries are there in defense. So there's a big challenge for this. So people are looking for some kind of automation, and the ecosystem to supply subsystems to the military industry is also not developed like the automotive industry because the number of units we buy in a year is very low. Okay, and the major problem we find is because of digitalization, many weapon systems are digital, software defined, etc., and use a lot of electronic components. So by the time we complete the design, test everything by the user, and ready to manufacture, serial production, manufacture means serial production, the electronic components have become obsolete. You don't get them anymore, right? Then again the military says, oh, now you're trying to give me a weapon system whose components are not proven, right? So we go through this cycle all the time. So our military manufacturing is a big challenge. So one thing I heard here is 3D printing is going to be mature tomorrow, right? So this is going to be a big boon for us. So we can use 3D printing. All you need is during the design stage, make the right CAD files and press a button and you get the output, right? See, we have a challenge of carrying spares in the battlefield. Okay, you have multiple systems and all of them, if you carry spares in another truck, the truck will be huge. You need a lot of spares to be carried. So one of the innovations in the industry was carry a 3D printer with the raw material, which spare goes bad, print that in the battlefield. Okay. So if that can be done in the battlefield at a higher cost, maybe the cost come down, we can do it in the regular factory also, right? So lot of innovations in the civil industry are being adopted. I only hope that we don't have to produce much weapon systems and we'll be having peace and only few will be developed, and as a deterrent it will be happening. So that's my prayer. Yes, we will develop and showcase, but don't manufacture too much, right? In the interest of the peace of the world. Thank you.
Thank you, Mr. Muralidharan. Over to you, Sanjeev, for opening remarks.
So good afternoon, ladies and gentlemen. My name is Sanjeev Kumar Singh, and I'm heading manufacturing at Aether Energy since last 1.5 months almost, where a very passionate and competent team is trying to change how we experience mobility, more than only manufacturing scooters. And before that, I worked for about 10 years with Bosch, where another set of highly competent, skilled, and passionate team is trying to change how we invent for life, and that's the tagline for Bosch, invented for life. And I think what I would like to start with is, if you look at EV industry, it's in its very formative stages. No more, I would say, a nascent stage, but it's still in very formative stages. It's not a question of whether electrification will happen or no. It's no more also a question of when it will happen. It's a question of how fast it's going to happen now. If you look at the theme, innovation, I think innovation has always happened based on the challenges the industry has faced. So if you look at the genesis of automobile itself, was an innovation because the challenge of mobility, how do we transport goods and people? From there, if you look at IC engines as an innovation and various processes which were innovated because of that, the challenges kept on coming from performance needs, from safety needs, from quality needs. I mean, why do we keep increasing from, let's say, when we would have started from 200 bar to a 2200 bar system, is to get more performance. So once people get used to one set of standards, we always want to go for the next set of standards. Now, if you look at EV segment, again, it's a need which has come, challenge of environment, which this EV industry is also trying to address in its own way, while also addressing how mobility is perceived from only being a product which can be used to an experience where you also feel the performance, what is coming out, feel the comfort, what is coming out, not at a very high cost. As I mentioned, innovation happens because the challenges. Now, EV industry is also having a lot of challenges. I think Shreyas also mentioned some of them. Chemistry, for example, in automobile industry, we have understood a lot of metal, but very less of chemistry. So we know how fuel behaves. But when we talk about EV industry, chemistry has a completely different dimension. If you look at IC, again, I'm just trying to draw parallels because I worked a lot in IC industry from EV industry. There are 3 or 4 or 6 or 8 cylinders which power the engine and drive your vehicle. Now, that is what is giving power. Now, if you look at an EV, whether it's a scooter or a car, there are hundreds and thousands of cells, probably similar looking, cylindrical in nature, but it's no more 3 or 4 cylinders powering the vehicle. It's hundreds and thousands of cells which are powering the vehicles. Now, what we have done so far on ICE to see how do we manage these 3 or 4 cylinders from the perspective of precision, from the perspective of thermals, let's take for example, is going to have a completely different dimension. And that is what is leading to a lot of innovation in EV sector. For example, if you want to have a consistent performance coming out of your vehicle, your battery has to continue to perform at a certain level, your battery pack. Now, if you don't manage to have the batteries or cells at a particular temperature throughout, it's not going to perform at the same level. Now, there are 2 dimensions to it. One is, it's no more managing 3 or 4 cylinders to keep them cool. It's about hundreds and thousands of them. Second, if you look at traditional ICE, where the energy efficiency is about 20 to 30%, from source to deliver, in an EV, it's about 85 to 90%. Now, a single percentage drop from 85 to 84 from the performance and experience of user is going to be a huge difference in comparison to what it makes from a 28% to a 27%. Now, I'm just trying to highlight some of the dimensions and challenges which the EV industry is facing, which is what is pushing it to innovate a lot, both in terms of design and R&D. I think Shreyas also touched on this, on the question of having R&D and manufacturing together. We at Ather are experimenting a lot there. And Mr. Mula also touched on agile way of working. And I'm very happy that in my new organization, that's the only way to work. So it's no more a manufacturing and design and development and supply chain. It's all swim lanes, what we call, or what we call cross-function teams or agile teams and scrum teams. Because I feel if you have to innovate faster, which is going to be the need of an EV industry, because the ecosystem is yet to develop, where we become a huge mass market setup, we have to continue to change our process at a much faster pace, because the design is going to change at a much faster pace. And with this I end. I'll be happy to take some questions, but I just wanted to set the context that the quantum and the challenges that the EV industry is facing today is completely different than what we have faced so far. And I'm sure this will help the industry as a whole to innovate at a much faster and a much larger scale. Thank you so much.
Thank you, Sanjeev. Sanjeev, if you can hold on to the mic, I'm going to start with you on while you talked about. I didn't realize till in the lunch when we met that you have the both sides of the coin. You have the IC engine experience and now you're on the EV. So you are the best person to answer this question. So traditionally, if you look at the manufacturing processes globally, just beyond the automotive, you look at Toyota systems, they're talking about Bosch manufacturing systems, or what a Mercedes or Ford introduced, and many of these processes have been replicated beyond automotive industry. Now, EV is disrupting the automotive industry. What process innovation in the process of manufacturing EV will disrupt the whole industry? Can you share some thoughts around it?
So, before I talk about what innovations probably, are happening and which are also likely to happen, I would also want to, based on my experience, make a statement. The fundamentals are going to remain. So, if you look at what Mr. Muller spoke about Bosch production system, it's nothing but lean manufacturing. Now, whether you manufacture a scooter or a power tool or a car, I think the fundamentals of lean are going to remain. So, I would say, on the ground, from how it should work, probably it's going to only get fine-tuned. What, however, is going to change a lot on technology part, and also a lot on how we, kind of experiment with those lean manufacturing setups to give it a different scale. To give an example, as I mentioned, if you look at, you have to manage the cooling down of hundreds of thousands of cells, or hundreds of thousands depending on which vehicle you have. Now a traditional cooling system, for example, of a water cooler, air cooled, what we have in ICE, can't work in EV industry. Now there you have to talk about a different way of cooling. Now what kind of chemicals you can use to ensure that the cooling remains at a certain level. There are phase change materials which are being used. To what extent we can experiment and innovate with what kind of materials can be used, alternative to what we have used in ICE, for example, is going to be changed, and that's what we use right now. So if you look at the piece of example, if I have to give, today the content of electronics and software in an EV, at least in India, is at a much higher level in comparison, let's say, to a traditional ICE. Now that gives a completely different challenge and a completely different scale. If you want to have on a vehicle line itself, with a takt time of 1.5 minutes when you're rolling out the vehicle every 1.5 minutes, and the software and the firmware content is very, very high. If you want to have that downloaded on the vehicle while rolling it out, you need to look at connectivity and communication in a completely different way. So these are some of the ways EV industry is changing processes. Yeah, and I think it's going to continue, and it's going to continue further also on the cell side. So if you look at the dependence still is there on lithium-ion batteries. So probably the industry is going to also look at this as a challenge, because the rare earth metals are also limited on what we can use. Can we rely only on lithium-ion? So probably there is going to be also innovation taking us towards a different material. And that is where the know-how on chemistry is going to be very, very important. Yeah.
Thank you, Sanjeev. Mr. Murli, question to you. You talk quite eloquently on the defense sector. And you also touched upon that the India's defense and aerospace sector is a little more like too much of manual manufacturing process. We don't have too much of automation. So where do you see the transition, and while automotive is very different, or let's say in healthcare is very different, what do you see as a need in terms of manufacturing innovation which needs to happen in the country to be a self-sufficient nation to make defense products?
Yeah. So thank you. Again, the defense technologies are changing. See, today we use a gun with a shell and a charge. Tomorrow the charge may disappear. It may be electromagnetic gun, rail gun. So technology in defense is constantly changing, right? So getting into automated manufacturing, because the volume is going to be difficult. So in India also, what we want to do is, we may not have the current defense technology of the world. But like the 5G, which is heavily software defined, the newer weapon systems are more net-centric and more software defined. Okay? So they may need more of electronics components and less of mechanical systems and structural systems. Okay? And they may depend more on laser beams rather than a shell going or a rocket going. Right? So with these newer technologies, we should be adopting them more and modernize the weapon systems that we have a step ahead of the rest of the world. So that's what we should be doing, and that's what we are trying to do. Like they say that there's a book by the name Army of None. In that book, there is no soldier. It's always robots and systems and AI and everything else fighting the war. So no soldier goes to fight the war. It's the robots and everything going to fight the war, right? So the military technology is changing the world over, catching up with the civil technologies. You have the automated car, autonomous car. Okay? So a weapon system can be autonomous. You don't have no need of a crew in the weapon system. It can be remotely fired. So you can fight a war in an air-conditioned office of yours, right? So the technology is changing. So with this change in technology, should we go back to the old technology and improve our manufacturing, or embrace the new technology and wait for these systems to be developed? Because nobody is going to share that data with us, the technology with us. And even if somebody gives a technology, adapting it to the Indian terrains, okay? See, India is the only country where we have high temperature and low temperature. See, our system should operate at -30 as well as +60 degrees. Okay? Many countries have either low temperature or high temperature. We have both. So we have unique requirements, use cases. So adapting a AI system from an imported machine learning system into India will be difficult for any application, not only for military. So we need to develop them all ourselves. So the question is, should we change our manufacturing or should we change our weapon systems themselves? Okay. So there's a big debate going on. What should be our next strategy? Okay. Now he's touched upon the EV industry. The EV industry is very, very encouraging for the military because many things are going electrical. So just one example, I said the military was the harbinger of all innovation. Okay? All the standards came from the military to start with. But now we are doing the reverse. So in the military defense systems, we are for software development, we employ a standard called MISRA. For example, if you want to code in C, we insist, or it's a standard that all the software coded in C should be as per MISRA C. Okay? For a long time, I was wondering what is MISRA. Okay, I thought it was a surname in Uttar Pradesh, and maybe somebody there invented this technique. But then somebody told me it is coming from the automotive industry. MISRA stands for Motor Industries Software Reliability Association. Right? So the C coding was not good in the automotive industry. They didn't want the car to be restarted every time like you restart your Windows. Right? They said there should be robust C code. So they came with some rules and standards for coding C, which the military has adopted. Now there is a military default standard. Unless you code in C, so we have a C code checker, which will check whether you have employed only MISRA C or not. Okay? So the military is fast changing. Right? Conventional warfare may not be the future. Okay? So are we getting ready to that is the big question. And second can be the manufacturing following that. So the ICT industry manufacturing can be readily used for this. So we can source most of the things from the civil industry, assemble them together. All we need is the specific software, or maybe some actuators and some few things like that. So world over is changing. So before we come to know, the industry would have changed. So that's why I was keenly watching the rest of the team talking about the changes in the manufacturing. So most of it, we'll be able to use that. Maybe the EV industry manufacturing setup is what we'll use, borrow many of them, reconfigure them to make a weapon system. Thank you.
Thank you, Mr. Madhusudan. Mr. Anand Kumar, you're from FANUC. So you're one of the right people to ask about robotics and how it enables smart factories and smart manufacturing systems.
Yeah, thank you. Of course, before I start, I would like to say, someone said one-man factory or something. So in Japan, some of our factories are unmanned. There is no man, no light inside the factories, of course. Okay, now, without taking much time, I would like to ask a slide over here, wherein I would like to show one welding operation using a collaborative robot. Most of you know collaborative robot where humans can work together with a robot safely. And in this particular thing, what you find more interesting would be that there is no skilled operator required to operate this robot. In fact, very layman can just use the robot by hand, just teach the start point and end point, and then the welding happens. So with this kind of an innovation, we see that the welding where the most of the robots are used today, even a common man can use, even job shops, or where the materials, where the batch sizes keep changing, you need not reteach every time. So I would request, please run the first video, please. Where you can see the person coming here, he is just moving the robot by hand. He is not doing any programming. This is called as a hand guidance function, what we call. He just needs to press the start point. He is just positioning the robot and just inform the controller that it is the start point. And he records it, and then he just moves to the next position. Just by hand again, he just says that this is the point, and then we have interactive pendants like this, which everyone is comfortable with. You can see the weld happens. The weld quality can be controlled manually remotely by the person. So it's so easy now to automate using robots for welding application. This I thought I will just show here. And the second one is on the machine tending application, where it's just a glimpse of how again the collaborative robot can be used, where there is no fixed position for the robot. It just takes the picture first. It had 3 marker points in front of the machine. and then the robot knows where its relative position, and then it just do the operation. So even if the robot position is modified, next time when the trolley is kept at anywhere else, robot still understands where it stands, and then it again works on it. So it's just a simple thing. And then as far as the cycle time is concerned and the space, you can see how closely the robots can move. You don't need a long reach or larger space nowadays. So this is what I thought I will show as an advancement in robotic automation today, which can be used, which is already in use in many industries. Thank you so much.
Thank you, Mr. Nandkumar. Back to you, Mahesh, where we started. I think you threw a lot of light on the healthcare industry, but I'm going to ask you in general, what are the digital transformations which are happening today in the global manufacturing systems, and where are we as a country, and where do you see the efforts which are needed to move up in terms of our own standards in the country?
So if you look at data sciences are fast transforming the conventional manufacturing for collecting data to real-time visibility. We're talking about data analytics, we are talking about auto-correction, and all those things are already in manufacturing. We also talked about, all the manufacturing, whether it's medical devices or automotives, to have your own MES system, to have your own ERP or PLM. And this were also very beautifully touched on the factory of future, or the factories that we are already doing now. So from a medtech, standpoint, I thought what I will do is, instead of dwelling on the same points again, let me pivot a little bit and talk about, what we call the daily management system, DMS. Now this is very, similar to what we talked about people, right? Everything is around people. So DMS is all about SQDCP, safety, quality, delivery, cost, people. How all this can be digitally interconnected so that right proactive actions can be pulled into the factories, so that hyper responsiveness can be put in place to fix the problems before they actually cause a line stoppage or whatnot. We will also dwell a little bit on a GPM system that we have gotten, and GPM system is nothing like it's similar to what you do when you fly an aircraft, right? When you fly, engine needs overhauling, engine needs maintenance. But whenever you are in the aircraft is always ready to fly. How does this happen? This happens because the moment the aircraft lands, whatever is needed to be done from a maintenance of the engine, whether it is to be redone, the aircraft has to be overhauled with another engine put in place, but the aircraft availability is always 100%. Those are the technologies we have to put in manufacturing with equipments, and we are already doing that. Our equipments are smart. They know how much has been the usage, what is the wear out. There are AI, guided intelligence that come in. What we are able to do is, we are able to fix the equipments and keep the OEE equipment efficiency to 100% so that there is no downtime. So I'll leave with that thoughts.
Thank you, Mahesh.